Labosha here. Good afternoon, kiddos. Today's mini lesson involves graphing linear inequalities. And so, of course, this lesson definitely pulls from previous lessons in terms of graphing linear equations. So in order to graph linear inequalities, you definitely have to draw upon your prior knowledge. And so let's graph this first linear inequality. That's almost as if it were in slope-intercept form, y equals mx plus b. And so we can graph it in very much the same way. I'm going to graph this first inequality using my blue marker. So my slope-intercept or my y-intercept is 3. My slope is 2/3. And so I know that I can start at 3. It's my starting point. Just like a linear equation, we only need 2 points to graph this inequality, to graph the line of the inequality. So from 3, our slope tells us to travel 2 units or rise 2 units up and 1, 2, 3 units to the right. There are my two points that I need to graph the line of this linear inequality. But before I graph this line, I need to decide whether or not it's solid or dotted. Now, prior to spring break, we talked about this. And so clearly, because there's an equal sign here, this line is included in this inequality. So that is going to be a solid line. Now, of course, I would use a straight edge or a ruler. Don't have one. Well, actually, I don't have one. It's okay. And so this is the line. This blue line represents the line of this inequality. Now, of course, because it's an inequality, I know that I have only divided this coordinate plane into 2 parts, an upper part and a lower part. And so I know that I need to shade one of those sides. And how do I determine that? So before spring break, we talked about using a test point. And so our most famous test point that we'd like to use is the one that's is 0, 0 if it is not a part of this line. The origin or 0, 0 is located here. And so I can use 0, 0 as my test point. Okay? All right, so 0, 0 is my test point for the first inequality. And so I know that this is my x, this is my y. I'm just going to replace y greater than or equal to 2/3 x plus 3. I'm just going to replace y with 0 and x with 0. So this goes away. And then I'm going to read and rationalize that statement. Is 0 greater than and including 3? And so, of course, the answer is no. 3 is larger than 0. So this is a false statement. That is not true. And so because this statement is a false statement, I want to shade everything. That's on the opposite side of where my test point was. My test point was located here. And so I need to shade everything above on the opposite side of my test point, which is this. And so what we have here, everything is true in this blue area for this first inequality. Okay, cool? Now we're going to do the exact same thing for the second inequality, except I'm going to use red. Here's my red marker. The second inequality, I'm going to graph it. It looks as though it's in slope-intercept form as well. My starting point is at -3. And my slope tells me, well, I have a few choices because it's negative. I could either travel down 4 units and to the right 3, or I can travel up 4 units and go to the left. And looking at my space on my coordinate plane, that looks like a better idea actually. And so from my starting point, my y-intercept, I'm going to travel up 4 units. 1, 2, 3, 4, stop. And then I'm going to go not to the right, but to the left because that's a negative slope. To the left, 3 units. 1, 2, 3, stop. And there is my second point. It's a linear expression. Okay, and so I know I just need 2 coordinates and I have them, my y-intercept and my second point that I found using my slope. Now, before I draw my line, I must decide whether or not this is solid or dotted. Very clearly, in this inequality, we do not have an equal sign underneath the inequality. So therefore, this is not going to be a solid line, right? It's not. It is going to be a dotted line. You really want to exaggerate. I do not have a straight edge, and so that's not the best line. But if I used a ruler or a straight edge, I'm expecting precision. And clearly this is not the best line. And so let's see if we can improve our situation here, make it look a little neater. Yeah. It's important to be as precise as possible, and using a straight line or straight edge, is what I'm expecting of you. And so I must also model what I'm expecting from you. Okay, so that's a better line. Better line here. And so let's erase this. Yeah, we want to be neat and precise. It's important. Okay. And so clearly we have two parts. We have our dotted red line, and we have a right side, if you will, or an upper side, and we have a left side or kind of a bottom side, however you want to see it. And so we must do the exact same thing we did here. We must decide which side we're going to shade in this inequality. Okay, because this is a system. This is a system. A system means that we have 2 inequalities that we're responsible for graphing on the same coordinate plane. And so we're going to do the exact same thing. I need a test point. Test point, clearly, here's my origin, which is located at 0, 0. Clearly, that is not a part of this line. So that's a really good, solid test point to use. And so my test point, please note I'm articulating what I'm using, which point I'm using to test. I'm looking for a true or false statement. And so given y is greater than negative 4/3 x minus 3, if I were to substitute y with 0 and x with 0, I would end up with 0 is greater than negative 3. Now I'm going to ask you if that is a true statement. Time. Give you a little time. Is that a true or a false statement? What say you? Is 0 greater than negative 3? Okay. If you said true, awesome, because it is true. 0 is greater than negative 3. Ms. Labosha, that doesn't make sense. 0 is nothing. Well, negative 3 is less than nothing. Okay? And so one way that I help students to understand why this is a true statement is to think about a number line, a simple basic number line. And so if we had a number line, well, we do have a number line. We have 2 number lines actually. Okay, if 0 were here and -3 here, we can see, we know that numbers infinitely get smaller as we go to the left, right? So negative infinity going to the left of 0. Numbers are they get infinitely smaller. Numbers increase infinitely to the right of 0, or just going to the right. Numbers just increase infinitely. So we can see that -3 is in fact smaller than 0. So this is a true statement. Cool? Excellent. And so my statement is true where? It's true where my 0, 0 is. Therefore, I'm going to shade everything above. Everything above. Kiddos, I hope you notice that we have, I don't know how clear that is to you, but clearly we have values that are red, values that are blue, and values that are what? That are what? If you said red and blue, you're correct, right? And so our solution to this system does not lie in answers that are just red. Our solution to this system does not lie in answers that are just blue. But our solution to this system lies in where our answers are both blue and red, which is right here. Blue and red. Blue and red. Okay. Questions? Shoot me an email. Have a wonderful day.